In this video, we continue on our discussion on discrete probability distributions and the associated mean and standard deviation. The first example we have here says that assume the distribution of the number of people per household in the United States is shown in the following table. So we have the possible values of x, 2, 3, 4, 5, 6, and 7, and the respective probabilities 0.27, 0.25, 0.28, 0.13, 0.04, and 0.03 for the respective possible values. Question A. Calculate the mean or the expected number of people per household in the United States. In order to calculate the mean, which is also written as mu, also known as the expected value of the number of people in the United States, we can use technology, namely StatCrunch in this example, in order to compute the expected value. We are also expected to, in part B, compute the variance, and in part C, to compute the standard deviation. In order to get started, I am going to key in these data values in StatCrunch. So I am going to go over to StatCrunch. So here I am in StatCrunch. I have the data values. I'll go to Stat, Calculators, go down to Custom. I'll have my values in X, weights in probability of X, and compute. And I have the mean and I have the standard deviation. So I'll take that back to my working bench. So here I am in my working bench. I can see that the mean is 3.51. So I'll take that back here. I have 3.51. And my standard deviation of x, I can write this as this one, or I can write it as this. It does not matter. It's the same thing. So this is equal to 1.284483. 1.284482. 1.28448. So here I have the standard deviation. Now, anytime you have the standard deviation, so standard deviation, and once you square it, that is standard deviation squared, this will be equal to the variance, always. And so that will be 1.28444843 all squared. That will be equal to 1.64989917. This is the variance. With that said, we proceed to the next example. In this example, we have an applied instance of expected value or the mean of a random variable. So we're told to suppose a life insurance company sells a $190,000 one-year term life insurance policy to a 22-year-old female for $270. The probability that the female survives that year is 0.999601. We are to compute and interpret the expected value of this policy to the insurance company. The emphasis here is that from the standpoint of the insurance company, what would be the mean or the expected value of this policy? To solve this problem, we begin with a couple of realizations. First, we look at the possible outcomes during this particular year. We have the possibility that this female survives the year or that female dies during that year. Then we're going to define our random variable x as the amount of payout. So our x here will be the amount paid out, and that will be the amount that is amount of money lost or gained during that year by the insurance company. Then we're going to look at the probabilities of x, That is, what are the probabilities of the possible outcomes? So first of all, take note that if this female survives during that year, as far as the standpoint of the insurance company is concerned, that means they are not paying this amount at all. What they have gained is $270 that year, and they are paying out nothing. However, if the same female dies, well, $270 has been paid in, but they will have to what? To pay out $190,000. So, what would that be? It means the amount they will be losing will be 270 minus 190,000, which is equal to negative 189,730. So as it stands, these are the possible values highlighted here. So along with this, we need to look at the respective probability that X is equal to 270 or that this person survives. According to the question, we are told that the probability that the female survives is 0.999601. So the other probability will be 1 minus 0.999601 because the sum of all probabilities is always equal to 1. So either you survive or dies. That will be the complement of this event. So let's get that value. That will be 0.000399. This is the probability here. So the values we need are 270 in this number, and this value, and this value. So all of them are highlighted here. Then to compute the expected value, that will be E of X, that is the expected value of this policy to the insurance company. We will need to go into StatCrunch. Let's key in the possible amounts of payouts and their respective probabilities. So I'm going to head on over into StatCrunch, and here I have keyed in all the possible values. So I'll go to Stat, go to Calculators, again go to Custom, and the values are stored in X, the weights in probabilities, and Compute. So I have my mean of 194.19. So taking that back, this is 194.19 in dollars. The interpretation of this is as follows. The company expects to make $194.19 for each 22-year-old female client it insures. The $194.19 of the insurance company is a long-term result. This is very important to note. And again, it will not make exactly that amount on each 22-year-old female it insures, but rather an average profit per 22-year-old female insured is this $194.19. Again, because this is a long-term result, this insurance idea may not work if they only have a few people that are insured as members of this policy. With that said, let's move on to the next example. In this example, we are told that in the game of relay, a player can place a $10 bet on the number 21 and have a 1 out of 38 probability of winning. If the metal ball lands on 21, the player gets to keep the $10 paid to play the game, and the player is awarded an additional $350. Otherwise, the player is awarded nothing and the casino takes the player's $10. What is the expected value of the game to the player? If you played the game 1,000 times, how much would you expect to lose? Let us see. To begin answering this question, a couple of things are in order. Usually when you play a game, you are interested in how much you can win from the game. So the variable here is how much that can be won. So in this case, I am going to let my x variable be amount to be won. Okay, and the respective probabilities or the likelihood that I'll win that amount. To begin with, this player places a $10 bet on the number 21. So if the metal ball lands of 21, the player gets to keep the $10 they already have, and then in addition, they get an additional $350. So the amount won is actually $350, and the probability that that happens is the probability that the metal ball lands on the number 31, which is 1 out of 38. Then, otherwise, if this player does not get the metal ball to land on the number 31, what happens? The player is awarded nothing, and the casino takes what? The $10 paid. So, what does that mean? There'll be a loss of $10, and you stand the remaining 37 out of 38 chances that this goes south. So, with that said, we are ready to calculate the expected value of the game to the player. So, the expected value, same as the mean, will be equal to, let us see. So, we'll go back into StatCrunch. We're going to key in these values and then key in this value in StatCrunch. So, let's go over to StatCrunch. Here in StatCrunch, I have all the data values already keyed in. Take note, 350 and then -10. I have that here. 1 divided by 38 on my calculator is equal to this first value, and 37 divided by 38 will give this value. So go to Stat again, calculators, and I'll go to Custom. Values are stored in X, weights and probabilities of X, and compute. And I have the mean in this case, which is -0.53 in this case. So the expected value in this case is -0.53. What does this mean? It means that the player would, if you were to play this game, you would expect to lose about this amount multiplied by 1000. So let me get a full version of this value. Let's go back to StatCrunch. We have -0.5263. Sure, let's take that back. This was, so the rounded off value for the sake of getting cents was actually this value, which we got back here in, StatCrunch. This is the mean in this case. And with that said, taking that back here, we have the mean. And if I multiply this value by 1000, it will tell me how much I am expected to lose. So if I were the player, I would expect to lose this value, 0.5263, times the 1000 times I'm playing the game. Take note, according to the question. If you played the game 1000 times, how much would you expect to lose? So it would be 0.5263 times 1000. So that'll be 1, 2, 3. So that'll be about $526.30, thereabout. Again, if you need more decimal places, corrections to decimal places, you will observe that this is 0.526315. Maybe we should do that. So let me adjust that. So here on the screen, I've adjusted the number of decimal places since it appears I might need it. So 0.526315 times 1000. So that tells me, to be more exact, that this will give me 526.32 in this case if I round it off to 2 decimal places. So that is how much I'll expect to lose. And with that said, we have completed that question. Then we proceed to yet another example of expected value. This question says that for a multi-state lottery, the following probabilities distribution represents the cash prizes of the lottery with their corresponding probabilities. So we're to complete parts A through C below. If the grand prize is $16 million, find and interpret the expected cash prize. If a ticket costs $1, what is your expected profit from one ticket? In order to answer this question, we pay close attention to the probability distribution table that documents all the possible cash prizes and their respective probabilities. In order to answer this question, what we'll do is to first find and interpret the expected cash prize. I'm going to key in all these data values in StatCrunch and compute the expected value. So in StatCrunch, I have all the data values here. So I'll go to Stat, Calculators, go to Custom. All values are stored in X, and the respective probabilities are P of X, and I will compute. So as it stands, the expected cash price here is this value, which is 0.297266678. So if I round this off to 2 decimal places, this will be 0.30. So the expected cash price is 30 cents in this case. So let's key that in here. Based on that calculation, the expected cash price is 0.30 to the nearest cent. Then we concern ourselves with what is the correct interpretation of the expected cash price. The correct answer to that is that on average, you will win 30 cents per lottery ticket. Then the next part of the question is, what is the expected profit from one ticket? If one ticket sells for $1, don't forget, if a ticket costs $1 to your pocket and you're making 30 cents back, well, that is a loss. So in other words, it will be 30 cents minus $1, and that will be negative $0.70. Now, the next question says, to the nearest million, how much should the grand prize be so that you can expect a profit? In order to get a profit here, we would expect that the expected cash price should be at least equal to the $1 you're paying. So the interpretation of this question is that we want the expected amount to be equal to at least $1. And how do we do that? It means that if we take out this 16 million as the grand prize, we are looking at what other value does it need to be so that the expected value is at least equal to 1. How do we do this computation? It means we'll need to multiply x by its own probability. We'll need to get all the other expected values and set it equal to 1. To make this computation easy, this is my recommendation for you. Take this as the unknown. This is your x. Multiply it by its probability. So you have x times 0. I'm going to write out all of this. So x times this value, that will give this value. Then plus the average for all of this, the expected value for all of this. I can do that in StatCrunch simply by deleting, or I can simply copy just this row. I'm going to cut that and take it somewhere here and paste. And then I'm going to go ahead and go to Start, Calculators, this time Custom. I also want to say that the values are stored in variable 5 right here, and the weights are in variable 6. And I'll compute that. The mean for that is 0.20526678. I'll take that back to my working bench. So here I am back in my working bench. I have the expected value for all the shaded parts. That is equal to this value. That is equal to 1. And so I'm going to subtract 0.20526678 from both sides. 0.20526678. So I have 0.12345678575x equals 1 minus this value. That would be equal to 0.794733322. And so to solve for x, I'll divide both sides by I'll divide by the coefficient of x, so that x is isolated. And on the right hand side, this should give me about 138214473. In millions, that will be this comma, that comma. So this is about 138,214,473. Back to the question, to the nearest million. So this would be rounded off to 140 million, approximately. That would be what the grand prize should approximately be. The last part of this question says, does the size of the grand prize affect your chance of winning? Explain. The correct answer to this question is no. The size of the grand prize is not affected by your chance of winning, because your chance of winning is actually determined by the properties of the lottery, not the payouts at all.